Welcome back. This is lesson 6 in unit 4, and today we're going to talk about mole mass conversions. Exciting! Okay, so in the last video we talked about how to calculate percent composition and how we used molar mass to figure that out. And so today we're going to continue using molar mass, but use that to help us convert between moles and mass. So the mole mass relationship, this slide kind of explains it, but we're able to determine, well, like if, for example, we say, oh, I have 5 moles of this compound, how many grams is that? Or if I say I have 5 grams of this, how many moles is that compound? So this little picture, when we'll revisit it later on, but when we're talking about going from moles to mass, remember, if we're starting with moles, you want that to cancel, so that goes in the bottom. If we're going from mass to moles, we flip it. Again, this will make a lot more sense when we actually go about doing questions, and we'll kind of recap this and revisit this at the end. But essentially, we need the molar mass in order to do this. Okay, so just like the last mole conversion question, we're going to work on 3 questions going from moles to mass, and then 3 questions going from mass to moles. So again, I'm going to show you all the steps. Doing it, we're going to be using dimensional analysis. So whatever I do is really for your benefit as well. So question number 1 says how many grams are 2.4 moles of sulfur? So 2.4 moles is our given. Put our given over 1. Now we want moles to go away. So moles goes on the bottom, and we're going to grams. So remember, grams over mole, you should think molar mass. So even if it's moles over grams, which we'll see on the next thing, moles and grams, if you see the two of those related to each other, again, you should be thinking molar mass. So we're talking about sulfur. So in 1 mole, because mole, so the number next to mole will always be 1. Grams, so this number right here is going to be the molar mass of sulfur. So look on the periodic table, sulfur is 32 grams, and that's it. So now all we have to do, make sure we set it up correctly, moles cancel out, we're left with just our grams, and so we're left with 2.4 times 32, which gives us 76.8 grams of sulfur. Now, if we are going to use significant figures, our answer should have 2 sig figs, so it should be 77 grams of sulfur. Remember, for multiplication, for sig figs, your answer should have the same number of sig figs as the number that has the least number of sig figs. Since they both have 2, answer has 2. Okay. Again, I'm going to try, I'm not going to guarantee that I'm going to remember out every single time, but try to use sig figs in as many of the calculations as we can. If you see a question, like a multiple choice question, and your answer doesn't match exactly, that's when sig figs come into play. So you'll see it rounded. But that's okay. Anyway, next, what is the mass of 2 moles of NaCl? So 2 moles is what we are starting with. Put it over 1. Now we need moles to go on the bottom, grams to go on top. And then right here should be the molar mass of NaCl. Now we have to figure that out because we don't know that right now. So let's take a quick little side note and work on this. We have Na, we have Cl, we have 1 Na, which is 23, plus 1 Cl, which is 35. Remember, you're just rounding to the nearest whole number. 23 plus 35 gives you 58 grams per mole. So now that 58 is what goes there. And now we're all set. So now we just do, hey, look, our moles cancel out. We're left with grams. So we get 2 times 58, which is 116 grams of NaCl. Okay. And then the last question, going from mole to mass, is what is the mass of 3.3 moles of potassium sulfide? So again, we have 3.3 moles. Put it over 1. We want moles to cancel, and we're looking for grams. So again, in 1 mole, we have so many grams. This is the molar mass of K2S. Now, since it's not given to us in the question, we have to figure it out. Most of the times, the Origins questions will give you the molar mass, I and mean, and then making you do more work. But it's great practice. We have K2S. For K, we have 2 of them. K has a mass of 39. 2 times 39 is 78. Plus our S, we have 1 of them. 1 of them to the nearest whole number is 35. 1 times 35 is 35. 78 plus 35 gives you, this is 32, my bad, can't read my own notes. 32, 78 plus 32 gives us 110 grams per mole. 110 grams per mole. Okay, so that's what goes up there, 110 grams per 1 mole. Our moles cancel out, left with grams. Yay, we set it up correctly. So we get 3.3 times 110, and that is 363 grams of K2S. And that's it. Again, using the dimensional analysis protocol, that makes this a lot easier. It does take some practice to kind of get through, but it's just kind of remembering that. Okay, so now with the last half of this, I'm going to give you mass, and your job is to calculate the number of moles. So, question number 1 says how many moles are in 9.8 grams of calcium? So we have 9.8 grams. That is our given. Put your given over 1. Now we want grams to cancel rather, so grams goes on the bottom, moles goes on top. Remember, for this conversion factor, we're talking about 1 mole. And down here, that is the molar mass of calcium. So if you look on the periodic table, calcium to the nearest whole number is 40. So grams cancel, you're left with 9.8 divided by 40, which gives you 0.245 moles, like that. So let's just pretend there's a dot right there. So that would be, if we're using significant figures, 0.25 moles. Okay. If there was no decimal point, that wasn't there, then it would round to 0.2 moles. Okay. As long as you're getting that, we're happy. Okay, number 2, how many moles are in 9.8 grams of aluminum iodide? So our given is right here, 98.3 grams, that you're given over 1. You want grams to cancel, so it goes on the bottom. We're looking for moles, that goes on top, with a little 1. So right here, in that orange box, should be the molar mass of aluminum iodide, which is AlI3, not given in the question, so we have to figure that out, making you guys do a little bit more work. AlI, aluminum, there's 1 of them in the formula, mass to the nearest whole number is 27, 1 times 27 is 27, plus our I's, we have 3 of them in the formula, each one of them has a mass of 127, 3 times 127 is 381. Add them both together, we get 408 grams per mole. And so that is what goes up there. 408 grams. So when we're talking between moles and mass, you always need that molar mass. I will make you calculate the molar mass because it is good practice. Grams cancel, we're left with moles. We set it up correctly. So that means we're left with 98.3 divided by 408. Plug it into a calculator, you get 0.24 moles of Al3. Okay, that's it. And the last question for this, how many moles are in 68 grams of copper 2 hydroxide? So again, 68 grams is our given over 1. You want grams to cancel, goes on the bottom. Looking for moles, that goes on top. In 1 mole, how many grams do we have? That is the molar mass of CuOH2. So we have Cu, we have O, we have H. Copper, there's 1 of them. Mass is 64. 1 times 64 is 64. Plus oxygen, our formula, we have 2 of them. 2 times 16 is 32. Hydrogen, we have 2 of them. The mass is 1. 2 times 1 is 2. Add 64 plus 32 plus 2, you get 98 grams per mole. Just like that. And that is what goes in there. 98 grams. Now our grams cancel. We are left with moles. So you get 68 divided by 98, which gives you 0.69 moles. And that is it. So here is your 1 slide recap. When you're given mass, so you're given the mass, you want grams to go on the bottom and your moles to go on top. So this is the molar mass of whatever you are looking at. So basically you are dividing by the molar mass. Now when you're opposite, given the moles going to mass, so you're given moles, you want your moles to cancel out, your grams. So remember, this is again your molar mass of whatever you're looking at. Molar mass is called of X. So here you are going to multiply by the molar mass. So that helps some people just knowing what to do. Again, here is demo, divide into moles, multiply when you're going out of moles. So that is there to help you. Again, I just like doing it step by step, but if you like, having these set rules, that is fine. When we get to the last conversion and we wrap everything up, you'll have a nice little cheat sheet for all the different conversions that you will be responsible for. Okay, so I'm going to leave this there. Enjoy. So the next video, we'll go over the third and final type of mole conversion. We'll go between mole and volume. And that's pretty much it. So, on that note, have a wonderful day. Bye.